All right, class. So today we're going to talk about how do we determine significant figures. And we saw this kind of with our last video on measurements and estimating the last digit. The uncertainty was in that last digit because it was the doubtful digit in an estimate. So we have to know how many numbers we can use and to determine the number of significant figures. So we're not always going to be doing measurements. Sometimes we'll just have numbers in problems or in front of us. So we still have to be able to determine how many digits are significant. So there's a couple rules. So rule number one, all non-zero digits are considered significant. Non-zero digits being 1 through 9. If I look right here, I have 1, 2 non-zero digits. 12 has 2 digits, so this would have 2 significant figures. I write significant figures as SFs just because it's easier. If I go to the zeros, our rules get a little more complicated. So I'm going to start with the easy rules, and then I'll go to the more difficult rules for the zeros. And I give them funny little names to help us memorize the rules a little bit better. So the first type of zero I want to talk about is the captive zero. So if a zero occurs between other numbers, so other non-zero digits, it counts as a significant figure. So if we look, this particular zero is held between 2 non-zero digits. The 1 and the 2 are non-zero digits. So essentially this zero is held captive. So it counts as a significant figure. So in this particular number, there would be 3 significant figures. In the next type of zero, because there's several types of zeros, it's referred to as the leading zero, okay? So leading zeros are to the left of other numbers, and they're used basically for placement value. It's to basically position the decimal point. Those aren't counted as sig figs. So if you look in this particular example, right, these zeros are leading zeros. They're just used to put that decimal in the right place, placement value. So in this particular number, there's only 2 sig figs. Why? The 5 and the 4 are non-zero digits. They count as sig figs. The numbers to the left are the leading zeros, and they don't count. So if we were to put this in scientific notation, you might remember this number is less than 1. We're moving the decimal over to the right 1, 2, 3, 4. We would write 5.4 times 10 to the negative 4. Negative because it's less than 1. 4 because we moved it over 4 times to get it behind the first non-zero digit of 5. And what we notice is when we put it in scientific notation, we're putting it with 2 sig figs. We were following that rule without even realizing it. So really the hardest example for significant figure rules are the trailing zeros. The trailing zeros is tricky because really there's 2 types of trailing zeros, okay? So trailing zeros, right, I'm going to circle those. There's 2 types. There's ones when there are decimal points, and there's ones without a decimal point, okay? So I'm going to actually go out of order and do B first. And this one I think is easier. If we look at this number 10,000, all these zeros, they're to the right of this non-zero digit. So they are referred to as trailing. They're trailing behind the non-zero digit. They are only used for placement value. They're basically saying 10,000. But we don't know if we were to make a measurement here, or if this number was only accurate to the 10,000th place. So maybe it was 10,000 people in this auditorium. So in this particular example, there is only 1 sig fig here. And if we were to put this in scientific notation, again, we would go 1, 2, 3, 4. We move the decimal over 4. So it's 1 times 10, and it's positive 4 because it's bigger than 1. And we're only doing 1 significant figure. Now, if we go to this particular example, we notice that there are still leading zeros, these don't count. But there is a decimal here, and this 0 is actually a trailing zero. It's a trailing zero because it's after the non-zero digits, but because of the presence of a decimal, this actually counts as a significant figure. So this would be 3 sig figs. If we were to write this in scientific notation, we would still use the rules for scientific notation and the rules for sig figs. We would move the decimal over 1, 2, 3, 4. So this would be 5.4, but we would add the trailing zero because it actually took place after a decimal times 10 to the negative 4. And in this example, there's actually 3 sig figs. Why? This trailing zero after a decimal. So I hope that helps. If you guys have any questions or comments, go ahead and put them in the comment section, or you can email me. And again, I appreciate your time and your patience, and thanks for listening.